All right, welcome to today's Explainer. We are going to take a seriously high-speed trip through the history of that little connection icon on your phone. We're going from those first crackly car phones all the way to the network that's, well, supposed to power our future. So let's just jump right in with a question I'm sure you've asked yourself.
Right? We see these Gs everywhere. 1G, 2G, 5G, but what does that G actually stand for? Well, it's pretty straightforward actually. The G just means generation. Every single G represents a massive leap forward in how our phones talk to the world around us. And really, the story of these generations, it's the story of how our entire world got connected. And this whole journey has happened pretty fast, over just the last 40 years or so. Each decade brought something totally new to the table. It kicked off in the 80s with just the pure magic of making a phone call while you were on the move. Then we went digital, got our first real taste of mobile data, and then bam, we hit true broadband speeds. And now here we are, in the age of 5G, building a network for something completely different.
To really get where we are now, we have to go all the way back to the beginning. Back to the first generation that made the whole idea of a mobile phone a reality.
So 1G, it was absolutely revolutionary for its time. But looking back, it was pretty basic. It was all about doing one thing, making voice calls from a car phone that was literally the size of a brick. It all worked on analog signals, kind of like an old AM/FM radio. And that meant calls could be super fuzzy, they could drop all the time, and security, forget about it. It was pretty much non-existent. All those problems with analog voice really set the stage for a huge upgrade. The rest of the world was going digital, and you bet mobile phones were going to come along for that ride.
And then came 2G. And wow, this was a game changer, especially with the standard that took over called GSM. By turning our voices into digital ones and zeros, calls suddenly became crystal clear, and for the very first time, they were secure. You could actually encrypt them. This digital trick also meant we could manage the airwaves way more efficiently. You could slice up a single radio frequency by time, which let a whole lot more people make calls from the same tower at the same time. The leap was just enormous. We went from this fuzzy, insecure, super inefficient world of 1G to the clear, secure, and efficient digital world of 2G. It was a standard so successful that it made international roaming possible for the first time. But 2G had one more killer feature up its sleeve. And what was that killer app? You guessed it. Texting. SMS. The ability to send just 160 characters of data. It was almost an afterthought in the system's design, but it completely changed our culture. It was the first real clue that these phones could be for way more than just talking.
So now the world was hooked on texting. And the next step was just obvious, right? We needed a real internet connection in our pockets.
So, enter 3G. Its whole reason for being was to deliver a true internet experience on the go. It used a brand new, much more powerful way to send signals through the air called WCDMA. And this was a technology built from the ground up for data, not just for voice. And the difference in speed was just staggering. 2G had this slow, clunky version of data that was okay for text messages, but that's about it. But 3G, especially after a few upgrades, delivered speeds that finally made mobile web browsing and even early video calls a real thing. This wasn't just an upgrade, this was the birth of the smartphone as we know it.
So, to juggle all this data, the networks got really clever. They basically used two main strategies. The first one, FDD, you can think of it like a two-lane highway. You've got one lane just for traffic coming down to you, that's your downloads, and another separate lane for traffic going up, your uploads. It's perfect for something like a voice call, where you talk and listen pretty much equally. The second method, TDD, is more like a single-lane road with a traffic cop who's just rapidly switching the direction of traffic. Now, this is way more efficient for web browsing, where you download huge web pages but only upload these tiny little requests. That flexibility became absolutely critical for the internet age.
Okay, so getting from 3G speeds to the crazy fast connections we have with 4G and 5G, that took some truly brilliant engineering. Let's pull back the curtain and look at the secret sauce that makes modern networks so fast. So the first big secret ingredient here is something called MIMO, and that stands for multiple input, multiple output. The best way to get your head around it is to imagine this. Instead of your phone and the cell tower having just one mouth and one ear each, MIMO gives them multiple mouths and ears. It lets them have several different data conversations all at the exact same time. Pretty wild, right? But we didn't just get to MIMO overnight. The tech evolved in these really logical steps. First, you just had the basic one-to-one link. Simple. Then, engineers got smart and added multiple ears to the receiver to make the signal clearer. After that, they added multiple mouths to the transmitter to make the signal more robust. And finally, with MIMO, we put multiple antennas on both ends to get the ultimate prize, a stronger, more reliable signal that also delivered incredible speed.
The real genius behind MIMO's speed boost is this technique called spatial multiplexing. For decades, engineers saw signal reflections and echoes as interference, a big problem you had to get rid of. But MIMO flips that on its head. It cleverly treats each of those echoes as its very own, separate data pipe. It literally turns a problem into a solution, which dramatically boosts speed without needing any more of that precious radio spectrum.
And MIMO is flexible. It can work in two main ways. You've got single-user MIMO, which is like firing all of its data streams at your one device to give you the absolute fastest speed possible. But if you're in a crowded stadium, that's where multi-user MIMO shines. It can split up its streams to talk to many different users all at once. That's totally essential for boosting the capacity of the entire network, so everyone gets a good connection. The second key technology is called beamforming, and the analogy here is perfect. Think of a normal antenna like a bare light bulb, just spraying light, or in this case, radio signals, out in every direction. It's wasteful. Beamforming is like putting a super efficient reflector behind that bulb to create a focused flashlight beam, and then aiming that beam directly at your phone. It means a way stronger signal for you and a lot less interference for everybody else. Now, all of these incredible innovations, more speed, more capacity, more efficiency, they weren't just so we could stream videos faster. No, they were laying the foundation for a network that could connect not just people, but, well, everything else. And that brings us to machine-to-machine communication, or M2M. It's pretty much exactly what it sounds like. Devices talking directly to other devices. They're collecting data, sending updates, triggering actions, all automatically with no human pushing a button. This is the very foundation of what we call the Internet of Things, or IoT. In this M2M world, it's not some far-off sci-fi future. It's already here, quietly running all around us. It's the smart meter on the side of your house that reports its own usage. It's the delivery truck reporting its location in real time. It's the vending machine that calls for a restock all by itself. Or the sensor in a farmer's field that tells the irrigation system exactly when to turn on. As you can see, the list just goes on, transforming almost every industry you can think of. And that right there, that's the real heart of 5G. It's not just another speed bump for your phone. No, it's the culmination of this entire generational journey. It takes all these incredible technologies we just talked about, like massive MIMO and beamforming, and puts them to work creating a network built from the ground up to handle billions, literally billions of these smart connected machines. You know, it's kind of funny when you think about it. For 40 years, we poured all this genius into building and perfecting a network for people to talk to each other. Now, the next chapter, the whole point of 5G and whatever comes next, is to build a network for machines to talk to each other. And that leaves us with a really fascinating question to ponder. It's not just about what we have to say anymore. It's about what are they going to say to each other. Thanks for watching.